If you haven't printed off this handout, please go back and do that now before continuing. We're going to talk about molecular formula. In the previous lesson, we talked about an empirical formula, which is determined by experiment, and it shows the lowest whole number ratio of elements in the compound. So, if we're talking about identifying ionic compounds, then that's enough, because the formula for an ionic compound is the empirical formula. But if we're talking about molecules, molecular compounds, that's not always the case. So for example, here I have two compounds. One is benzene, one is acetylene. They have the same empirical formula, CH, because for every one carbon, there's one hydrogen. So if we are working in a lab trying to identify compounds, we need another way to get the actual molecular formula for the compound we're analyzing. Because we need to know, is the substance benzene or is it acetylene? There's a big difference. So this is what we're going to talk about today. And really, most of the work we've seen before, with a few differences. So we're going to start by finding the empirical formula the same way as we did before. And in addition to that, if you're actually working in a lab, you'll use something called a mass spectrometer or a combustion analyzer. So both of those devices can be used to determine the molecular formula. So let's go to the example. So we're talking about the fluid in a lighter. Somebody analyzed it using a combustion analysis, and the instrument showed the percent composition. So we know that this substance is 82.5% carbon and it's 17.5% hydrogen. That same sample was put into a mass spectrometer, which determined the molar mass. So the molar mass of the sample was 58.123 grams per mole. So that's enough information to figure out the actual molecular formula. We're going to start by filling out the table just like we did in the previous lesson. So we'll list the elements in the compound. We know there's carbon and hydrogen. Now, if you'll recall from the last lesson, we can take our percent compositions and just turn them into a mass in grams, because we're just going to assume a 100 gram sample. So in a 100 gram sample of our substance, there would be 82.5 grams of carbon and 17.5 grams of hydrogen. So we need the molar mass in order to determine the number of moles. So when we look up our periodic table, carbon has a molar mass of 12.01 grams per mole. Hydrogen has a molar mass of 1.01 grams per mole. Using our formula, mass divided by molar mass, we can calculate the number of moles of each element in our 100 gram sample. And now we're going to continue on to find what's the ratio of carbon to hydrogen. So to do that, I find the lowest mole amount, which is 6.87, and I divide each molar amount by 6.87. So I end up with 1 and 2.52. So that's roughly 1 to 2.5. So if we change that into a whole number ratio, that would be 2 to 5. So we would say the empirical formula for this fluid in the lighter is C2H5. If we had a molecule of C2H5, what would be its molar mass? Well, there would be 2 atoms of carbon and 5 atoms of hydrogen. So to get the molar mass of that compound, you would take the molar mass of carbon, multiply it by 2, and add the molar mass of hydrogen times 5. So I'm hopeful that you're able to calculate the molar mass of C2H5. It would be 29.07 grams per mole. Now here's where we're going to figure out the actual molecular formula of this compound. And we have to look right here. So this is how we do it. We take the actual molar mass found by experiment using the mass spectrometer, and we divide it by our empirical molar mass, which we just calculated here. So if I go back up to the question, it says the mass spectrometer gave an actual molar mass of 58.123 grams per mole. So that's our actual molar mass. So we're going to set up our calculation. We're going to do 58.123 divided by 29.07. And that equals 1.999 with the correct number of significant digits. That's roughly 2. So what that means is our actual molecule is twice what we expected based on our empirical molar mass. So the empirical formula was C2H5. Our actual molecular formula is going to be twice that. So all of the subscripts in our empirical formula are now multiplied by a factor of 2. So the actual molecular formula of butane, the fluid in the lighter, is C4H10. So just to briefly recap, to find a molecular formula, you need to start with percent composition or mass data, figure out the empirical formula, find the molar mass of that empirical formula, and then determine how much bigger your actual molecule is than your empirical one. In this case, it was 2 times, so all the subscripts in our empirical formula got multiplied by 2. So that's how you do it.